Contrast Security secures the code that global business relies on. It is the industry's most modern and comprehensive code security platform, removing security roadblock inefficiencies and empowering enterprise developers to write and release secure application code faster. The Contrast platform automatically detects vulnerabilities while developers write code, eliminates false positives, and provides how-to-fix guidance for easy and fast vulnerability remediation. Learn more about the Contrast platform at securityweekly.com/contrast security.
Imperva protects applications wherever they live and at the pace of development. From securing applications at runtime to protecting APIs in any cloud environment, only Imperva offers a unified solution across edge, application, and data to help you achieve more and save money. Start a free trial today and quickly protect your web applications at securityweekly.com/Imperva.
Welcome back to Application Security Weekly. We just talked with Farshad Abbasi about choosing tools and processes to help build secure code and how threat modeling can be a key part of that. I'm your host, Mike Shima. I'm here with John Kinsella and Joe South, and this is our news segment. 2 announcements real quick. Don't miss any of your favorite Security Weekly content. Visit securityweekly.com/subscribe to subscribe to any of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, Discord server to chat with us right now, and follow us on social media and our streaming platforms. Plus, don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. And as I take in a big breath, because I've got 2 folks here with me, John and Joe, to talk about the news. And it's been 2 weeks, as John pointed out, very kindly, since we talked. So there is quite a bit of news to go over. I'm just going to kick us off real briefly with an OpenSSL security advisory that I don't think needs too much discussion, but has a wonderful quote in it that I think sums up a lot of maybe perhaps the state of aspirational InfoSec. Part of the advisory says, note that on a vulnerable machine, proper testing of OpenSSL would fail and should be noticed before deployment. So I think if we could just add that phrase to pretty much all of our software packages, John, Joe, the 3 of us could be out of a job because everything's going to finally be secure.
Our job is done. Congratulations.
Yeah. It was brief. Sorry, Joe. You show up, and then this is the last episode.
We're already done.
We're already done. But perhaps it's not going to be quite so easy because there is not quite a tempest in a teacup, but I think a lesson in something to learn. I lost my alliteration there. Apologies. But the Python package index is doing a wonderful thing along with NPM and some of the other OpenSSF and Foundation are pushing package management systems or package platforms to move all of their to move to MFA, to 2FA, things like basically making it more secure. Here goes my brain. But as an example of some of the hurdles of adopting 2FA, a package owner on Python said, I don't really want to bother doing this. And so they pulled their package, creating a left pad type of scenario from NPM where that because this critical package, critical being measured by just popularity of downloads, disappeared. A lot of folks' builds started failing, and the package owner said, okay, sure, I'm going to throw this back up there, but I'm still, just so that builds don't break, I'm still not going to take up, enable 2FA for my repo because I don't want to bother with it. And by the way, if you're using Python 3, it has 2 functions that basically work for this package's use case anyway. So there's a couple things to unpack there, but I've been doing all the talking so far. So let me throw over to John or Joe, who wants to chime in with some different background on this or some ideas on what some lessons we could learn from here.
I don't know. There's always, at least for me on this one, it's just there's always going to be someone who wants to take their ball and go home, right? It doesn't thrill me. I think there's depending on looking at whichever of these package repos we have out there, from Docker Hub to PyPI to even really some of the Go stuff. So all these different, most languages nowadays end platforms have some sort of this thing. Kubernetes has it too with Helm and a few other ones. There's some level of trust that people aren't going to take their ball and go home. So we've seen this a few times over the years now with, it's usually not quite this blatant. It might be more either someone's doing something in protest where they're putting something malicious into the code, or someone else gets access to it and they put something malicious into the code, or like I said, we have this kid here, or excuse me, this person with takes their ball and go home. So it's, I don't know, the Python or the Python 3 aspect, as you mentioned, is interesting. I focused more on just the thing itself and what do you do. I don't know. At the end of the day, it's not a good look for me, right? It's all of us who are doing anything in public in this. We've got a paper trail behind us for people to see who we are and what we've done. So good luck on your next interview, I guess, would be my sort of point of view on it.
I wonder how much. I wonder how much testing actually went into it, and how much, review took place to try and catch it ahead of time.
I think that's what highlights this. It's the interesting here is that, especially with supply chain, there's a lot of testing that you're going to get surprised about if your package just disappears, because, as John said, somebody just wants to take their ball and go home. And I think maybe there's that combination of responsibility for, of course, testing and having robustness of your code, as well as if you are going to create a critical package, or let's use the synonym in this case, I think popular package, there is a responsibility to make sure it can, there's confidence in the security of it, so it hasn't been tampered with. So I do think that Python and NPM and others are doing the right thing here. Perhaps there could be a lesson just on communication and support, because I think one of the aspects is we could also throw a FIDO key, finance a FIDO key for all these developers. But when you get into account recovery, and somebody says, I lost my FIDO key, and now you don't have someone who just didn't want to adopt, you have potentially someone who did adopt but lost their key, or somebody's maliciously, rather than attacking the workflow around the 2FA process, attacking the workflows around the account recovery process, which is part of the threat modeling that Farshad was reminding us to think about.
And you're touching upon something interesting. It's the whole usability of security thing, right? We've had on folks from Linux Foundation and other places over the years of I think the number's changing, but it used to be for a decent percentage. It's probably closer to 50-50 now. People are either commercially supported to work with open source, or if they're actually doing it for the love and on their spare time. But especially for that second group, we have to make this as easy as possible. As you're adding security, if you're increasing the amount of hoops people have to jump through, particularly what you just said, around account recovery, the thought that popped through my head as you're saying is that this can't be like Apple, right? If my little God device somehow that gets locked up and I'm out of it, I'm done, right? There's no real way to get back into it. So how do you? There has to be some sort of middle ground where a human can actually reach out and talk to that person or know that person. Maybe they're hopefully part of a community and someone can vouch for them, or there has to be some way to do that side of it within reason.
Yeah, it's definitely getting into the idea of web of trusts. But you mentioned Apple, which we'll come to in a second. But John, you pulled out talking about vulnerabilities. For those, I think, I can't remember whether you drive the McLaren or the Bentley, but for those of us who drive lower price cars like Hondas, there's a vulnerability out there that we need to be worried about. What is it?
It's the Bentley this week. The odd and even weeks are the McLaren and the Bentley. Bentley. So this is and I actually didn't get the link I wanted to in here, but it's in this blog post. So hat tip to Hackaday, which actually isn't hacking the way we think of it, but more hardware side. But the second paragraph has a link to the technical overview of this. So what happened here? Briefly, Honda has the ability, and I'm sure most car manufacturers have something like this. When you go chirp chirp on your little key fob, it unlocks the door, but that code which goes across is usually what's called a rolling code, right? So you can't replicate it and reproduce and have it go again. One of the tricks which Honda has in place, let me be a little more clear on that. So the rolling code idea is as you keep going click, 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 click on your remote, that the code changes each time. And that's a forward-moving process, right? So you can't go back and replay an old code. And they use what's called a sliding window. So maybe the next 2 or 3 codes ahead are legit after one has been accepted. So that window keeps going, and you can only do within 4 or 5 of those predetermined codes, and that's the pattern there. So what someone figured out, and this is done so you can't do replay attacks, and that usually works. What someone's figured out is there is at least I couldn't figure, I didn't look too closely, or I didn't dig too far, let me say it that way. Someone has figured out there is a sequence of lock-unlock commands which you can send to a Honda car, which then resets that index pointer on the sliding window, and then you can go back and replay the codes which were outside that sliding window before. So it basically means that you're able to, do what you're not supposed to do. But what's interesting about that is, beside the fact they test on a bunch of different 2012 Honda Civics. It sounds like they all use that key fob, so it's probably more than just the Honda Civics. But there's a CVE out there for it, 2021 46145, for those keeping track. But the bigger problem here is Honda's decided they're not going to do anything about it. So, yeah, there you go.
Yeah.
I saw something that, and this was, I think, a couple weeks ago, where carjackers are now, they figured out a way to do a replay attack on your garage door opener. And so it'll open the garage door, and then they do another replay attack on your car to unlock it and get into it. And they're closing the door behind them, obviously, and people are waking up finding that their car is no longer in their garage.
That would make me an unhappy camper. I mean, think about it though, right? Usually your remote, if you're in your house, your key fob is maybe a floor away, maybe just a room away from the garage. So if someone's able to get there, even with the the keyless entry type stuff, once you get through that flimsy little garage door, that's not fun to wake up to. I don't like that idea.
Yeah, and it's, you mentioned too, Honda, the 2012, and the list does go up to makes through 2022 as well. So this is not just an old attack. And it is interesting to talk about threat models and proximity of people. How close do you need to be for this? So I guess maybe the reason I'm kind of touching on that part is that if you want to do some practice threat modeling with your developers, lots of people drive cars. This is a great way to start that attacker-minded thinking, to say, how could we open the garage door, as Joe pointed out, grab the car, and play around with your whatever Fast and Furious number they're on now, but set that up as a fun exercise for your engineering team.
Stole my Street Fighter joke, but go ahead.
All right. Well, think of another. We'll have to think of another joke for you while we talk about the next topic. Wiz, we've talked about a couple with them in the past. They've got some great vulns, as well as they've been talking and touching on something that you, I think, have been paying attention to quite a bit, John, about cloud CVEs. So Wiz has now launched the CloudVulnDB.org, which is a open source tracker for CVEs or CVE type problems within the cloud. And there's a couple things that we should get into, but one of the things that stood out for me that I didn't appreciate initially was the motivating reason for this is that the CVEs actually have a requirement that the flaw has to be fixable by the consumer. But if it's something that if it's a flaw in something that is not really consumer controlled, or as they're describing, depending on like a shared control or that shared responsibility between the end user, the consumer, and the cloud security provider, that's not something that really falls into a CVE classification by their rules. So it was pretty interesting, just in the sense of, we should have something like this to be able to track vulnerabilities, but we don't, because some of the rules, perhaps, I think it's safe to say CVEs weren't written with cloud in mind, because they date well before cloud was a big thing.
Wow. I have to admit, I hadn't heard that one before. Does that mean let's go see real quick. Does that mean with that CVE on the Honda that the consumer should be able to fix their key code?
Yeah, exactly.
That's interesting. Joe, I interrupted you. Go ahead.
No, I interrupted you. I'm sorry about that. Yeah,
no, really,
I never heard of that rule either. That's really interesting, because that wouldn't apply to the cloud really in a lot of cases. And so I guess that would make a little bit of sense as to why we don't see more cloud provider related CVEs. It's more of like a vulnerability disclosure, like a briefing,
Right.
rather than an actual CVE with it.
And I think some of it, to pick on an example, some of that we've also seen. Oracle security is another one that hits. So that everybody likes picking on Azure. I think we've covered quite a few of those. But some of the vulnerabilities, they are found by a third party, but then they're fixed by the cloud service provider, by Azure. So I think one of the premises here is that, well, how do we know whether or not a vuln existed in the first place in our cloud hosted MySQL service, and if it was present and fixed, it's still important to know what was the time frame of which I was potentially vulnerable. So I think that's actually one of the motivating factors here too, is that even if the Amazons, Googles, et cetera, are fixing these flaws, having a sense of when I might have been exposed is still important. And I think that's why, without getting too hung up on the details of specifics of a CVE, just saying, here was a flaw, we should know about it and say, either did the service provider fix it because it was their responsibility to do so, but what should I do about it? I guess the what should I do about it is always what comes back to me about this in terms of just what are the good calls to action that we would hope to see come out of a vuln database like this.
Yeah. And to go back to your original point on this one, so this is Wiz. When I was tracking these a few months ago, time flies. Wiz had this one, which they're now sort of coming out of making official, GA 1.0, whatever you want to call it. There's also one from Cloud Security Alliance, which I thought these guys were going to work together on, so I'm a little surprised, but I haven't been watching every single day. They've got global security database, so we now have two competing standards. I hope not. I hope they I think they're going to somehow be able to mesh together. But yeah, I think it's probably really the benefit for someone like Wiz, right? From the point of view of just thinking through what you're saying there, Mike. Imagine I'm on, I'll say Amazon just because it pops to head, and I'm using their database as a service RDS, and say I'm using it with Postgres. Okay, cool. Let's say MySQL. I know the version number's better. So we're using Aurora DB RDS on Amazon, and there's a vulnerability in 5.7 1 through 5.72, but I just switched over to start using version 8. So, how do you actually, this isn't, even someone scanning outside isn't going to notice this, right? You have to be able to have access. You have to have an authenticated scan, basically, not of my application, but of my cloud provider. So it seems like someone like Qualys or Wiz, one of these guys that are able to go in and do that type of scan, this is where this type of data becomes handy to say, hey, this thing you're using, this particular version of it, or you have to, change your key, or you have to do some sort of configuration change to make it secure. So there's definitely value for it, and it's I think one of the things which comes in handy if I put that previous life vendor hat on. You have the customer coming into you saying, I've got this, I don't know, what are they calling these? CVEs? We'll have to come up with a name for them. We have the CVE-like thing. It said I'm vulnerable, but I don't think I am, so how do you prove or disprove or what's going on? So you have to go back through and start doing this verification and validation of it. But if you have definitions around those, is where I'm going, you're talking the same language. So it definitely is going to be used by a lot of folks, I think.
Yeah, so we'll definitely track it. Love to see how it would be used by those folks. And you set up a great segue there, John. There's a common language here that's being developed, or a way to talk about and categorize these CVE-like things within clouds. I've pulled in a white paper from NCC Group about practical attacks against machine learning systems, and against machine learning systems. And listeners, for those of you not seen the audio or video, I had to do the jazz hands for ML, and this was ideally it's pointing out code is code, and there's a lot of things like path traversal that gets called out, but basically, all of the original OWASP top 10, those style of vulnerabilities will be found within ML frameworks, etc. But it gets into section 5. It talks about a good way to classify, or maybe just to categorize and talk about various types of flaws that can come out of a machine learning, both their models and their data sets. It has two other things. One, some good conclusions that point out that these aren't necessarily the highest risk things to be thinking about, but work with your data science teams on threat modeling. Keep these types of attacks in mind. And it has a massive section of references. So if this is an area you really want to learn more about, there's quite a bit of reading you can do beyond just this particular white paper if you just pick out all the references it has at the end.
Mm-hmm. Mm-hmm. Joe, thoughts?
That's pretty interesting. You know, it reminds me of when a popular EDR was bypassed or kind of tricked into thinking that malware wasn't actually malware, because an attacker learned how to teach the ML under the hood that this malicious file wasn't actually malicious.
Yeah, they've got some great examples down on where are they? Page, what is this? 12 through 16, where they take, you know, some of the standard images that might I'll hit the first one. They've got an image of I guess it's a Bernese mountain dog. The ML figured out pretty quickly. And yes, Joe, when you're on Application Security Weekly, we have to do rainbow hands when we talk about machine learning. But so the first version of it here, it got the mountain dog. So the top 2 or 3 inferences are mountain dog, English Springer, greater Swiss mountain dog. You know, we're seeing a pattern, right? The ML recognized this thing's a dog. And they perturbed the image by running it through some static, or maybe they might have changed. I can't remember. I didn't look too closely at the details, but they might have. Here's me looking at images again. God, I'm so predictable. But they, it looks like they either decreased the quality of the JPEG image or they ran some static across it, and it still is a human, right? That thing a dog, but the inference system went from going, you know, dog to golf cart, feather boa. Oh, it got Bernese mountain dog as number 3. Sulfur crested cockatoo, Afghan hound, mobile home, umbrella. So like it quickly just sort of lost its ability to do anything just by putting a bit of noise into it. It's a really great paper, I thought. You know, you mentioned, Mike, that the TLDR, the conclusion up front, there's like 2 or 3 points in there, just really quickly hits that are quite good. You know, basically training an ML system using sensitive data appears to be fundamentally unsafe. You know, that'll let you sleep well at nighttime. Neural network classifiers appear to be brittle in the sense that they can be easily forced misclassifications. And then the third one we haven't talked about. Yeah. So I think this is an interesting one to sort of bounce around, probably for upcoming episodes too, guys, is, excuse me, when you're training an ML system, right, you need, if you're going to do a big data, again, rainbow hands, and you're going to do this very large sort of scale of training this system to be able to recognize like GPT-3 or facial image recognition, right? These sort of big popular things we see driving cars. Usually the result of all that training, which happens across at least hundreds, if not thousands of systems, comes back down into something which, you know, you can put into your pocket or into the back of the car, something that's a little more compact. But that means that the actual model, which has been trained, really what training is doing is sort of shifting numbers around, trying to get things to line up and make the dog look like a dog. That's why when you add some static into it, suddenly the computer think ain't no dog. But so that thing now comes down into your, like I said, the phone. But that means the model is on the phone, which means someone with malicious intent, sort of like what you were just hinting at there, Joe. If it's a AV system, or EDR, excuse me, don't call it AV anymore. You now suddenly have the ability to get that model and start doing some testing offline without people being able to see what you're doing. I haven't seen that tested much as I would expect it to, so maybe that's going to be a future path for some of these folks to start playing with. I mean, I guess where we've seen in past lives is, you think about spam. So people started using some of the open source spam systems and running their spam through to see how they could tune it and adjust it so that it wouldn't set off the spam filters. So maybe we're talking something sort of that's a similar analog to it, but I think that'd be sort of fun to watch in the future.
Absolutely would be fun. I think the summary I can throw in here is, this is clearly an adversarial environment with any of these ML systems, from perhaps obvious adversarial when we get into face recognition. And we've seen, I forgot to pull in some examples, but we've seen some examples of makeup face paint that is resistant or perturbs, messes up the facial recognition, as well as clothing. So we do have a cyberpunk future ahead of us, a good dystopian one, unfortunately. Perhaps not too dystopian, though. Speaking of Apple, it's got mentioned once or twice, they have a new lockdown mode for their iOS devices, for a lot of their devices, for their OS. They announced this at WDC, amongst a couple different things. But what lockdown does that's pretty interesting is that it basically reduces the attack surface of a phone, for example, by just saying, no, messages aren't going to render links anymore. They're not going to pre-render within iMessage. So they're not. So we've gone beyond just a sandboxing of components, building up things like the blast doors within iMessage, Safari doing process separation, a lot of architectural changes, into, unfortunately or fortunately, depending on your perspective, the reducing attack surface in the sense of disabling a lot of features. Now, the reason I threw a little bit of unfortunate aspect in there is that, on the one hand, this is for very targeted, high-risk users. So amongst the perhaps billion of people with an iPhone, it's a percentage of a percentage where this is really going to help. But it still is, I think, a good way of thinking about security that is in addition to architecture and security architecture, security bug bounties, security scanning, also getting rid of code or disabling features, or just summarizing that as reducing attack surface, still a viable security mentality. So I think that was the area I could exhaust myself on this particular topic now with what I wanted to hit on it. So I'm not sure, Joe or John, you've got anything to add there? Or we should hit one of the other articles.
I think it really highlights how Apple prioritizes the security and privacy of their customers. Just giving you that option to have that enhanced, security feature beyond their already, fairly secure security architecture. It's nice to have. It's nice to see. I wish more companies out there would do things like this.
Interesting. It's they seem, if you look through that list, as you were just reading them off, Mike, they seem like sort of standard hardening concepts. There's nothing really wild here, right? It's not like, as we're just talking about Gatekeeper and some of these other things. It's not super nifty high tech. They spend a lot of time. It's like, let's not render images, or the web browsing one's going to be interesting, because we've been talking in previous episodes about, at least I think it's a matter of time until Apple's going to have to allow others to allow use of other web rendering toolkits on there, not just WebKit. So how then do you do JIT how do you control JIT if it's someone else's? Wired connection one is good. Apple services, sure. So yeah, we can hop onto the other Apple Store or wherever else your lovely mind wants to go. But it's definitely, I think it's a good thing. I'm sort of curious to see how many of the security hipsters out there, and hell, I might fall into this camp on this one, might turn us on, just even if they're not high net worth or high target individuals. They can start getting people saying, "I'm sorry, I couldn't read your message because I've got my security stuff turned up." Let's see where that type of stuff goes.
We'll see. It does have, I didn't pull the article into the show notes for this week, but I was tracking it. Microsoft went back on they had said, we covered about a month ago, saying they're going to disable Excel macros by default. But now they've said that actually we're not going to turn them off by default. We're going to leave them on. And the reason I'm tying that into this is that, John, you were pointing out the idea that, disabling, there are hardening steps to take. And some of the questions about that is, perhaps Joe was pointing out too, is that, do you do these by default, or do you have users opt in? With Excel, Office macros, we've seen that it is clearly an attack vector, but so few people opt into it. It seems smart for Microsoft to say, yeah, we're just going to turn this off by default, and that way everybody benefits from the security. But if we get out of the big organizations that with dozens of people, if you have any security team, especially if you can have it in dozens of people, maybe that's a little bit more viable. If you're talking about small, medium businesses that maybe rely on Excel and Office macros a little bit more, that could be potentially catastrophic to their business workflows. So definitely some trade-offs there. And I suppose maybe some food for thought about how do you decide on what should be that secure default. Speaking of high net worth, there is one. Let's finish up on another hardware hacking. So we talked about cars, and this is now talking about cryptos and cryptocurrency. So I found a write-up about a hardware wallet, which is used to basically to sign transactions, because signing transactions is important if you're moving around the bits that represent some sort of currency one way or the other. But what's interesting about this is that some fun research, a nice write-up that was pointing out, saying that there is design intent of this hardware wallet where it's supposed to, after 30 failed attempts of logging in, this wallet erases itself. So therefore it is, speaking of catastrophic, can block any further attempt to brute force the passphrases for this, as well as it had a 4-byte, if I'm saying it right, 4-byte pin challenge that had ultimately could be brute forced, because rather than being a large 16-bit address space, key space, of trying to guess, they dropped it down to only about 1024 guesses necessary to bypass the pin that was protecting this hardware wallet. So it's the type of thing that the premise is, have a hardware wallet supposed to have some good security guarantees on it to prevent brute forcing, to prevent if anyone picks it up, they can't impersonate you just for guessing your 1, 2, 3, 4, 5 combo on your suitcase. But that was bypassed with a couple links to some software and hardware tools. So pretty fun, good research, kind of not quite hobbyist, but just a good combination of hardware software. And I think I've exhausted that one in particular. So I don't know if there's anything else there, or if Joe or John, you've got a final article that you want to end us on, maybe.
We got a few good ones. Let's see. Actually, did we hit the Lockbit one yet? We didn't hit it today. I can't remember if we hit it previously.
No, we didn't. No. Bug bounty.
This is So we're I think everyone knows we're a fan of bug bounties here on Application Security Weekly, and we've talked a lot about different organizations using these and how they're able to drive improved performance and security handling in their organizations. It turns out some of the ransomware guys think this is sort of a good idea too. So this one in particular is for Lockbit, the ransomware gang that they've been leaving a trail of carnage for the last year or two. And what they're doing in this particular instance is they have created a come on, brain. They've created a bug bounty program, and I'm looking for the numbers. I remember. Yeah, there it is. So depending on the actual thing here, they will pay out to either ethical or unethical hackers anywhere from $1,000 to $1 million. And what they're looking for is not specifically a bug. So this is where it becomes, it's not quite like our normal bug bounty programs, but they're looking for PII, personally identifiable information on high net worth individuals. So we can tie it back to that high net worth thing also, Mac. Mm-hmm. Actually, and web exploits. So it's both, not just, before when I saw this, I just saw the first part of that. So they're realizing that, while they've got some good guys and they can do some good hacks and they're becoming fairly successful at what they're doing around the world, hey, let's give this bug bounty thing a try and see if we can sort of improve our leverage, our capability to leverage those vulnerabilities as well. So I think that's sort of interesting. We'll see how. I know if we're going to have an ability to. Oh wow! I don't know if we're going to have the ability to actually track how this goes over term. I mean, we've seen what Microsoft and Adobe, I think, and some of the other, and Google, Maybe not Adobe. I think Adobe actually at one point were talking about how much they're paying out on their bug bounty programs. So does this mean like in 6 months or 12 months we have Lockbit actually putting out a press release saying that in 2022 they released? I mean, I could almost see them doing that sort of as a finger in the eye. They paid out $375,000. Yeah, but I don't know. A little different, but I thought that was fun.
Little different. It definitely points out too, for speaking of threat modeling, make sure that insider threat is on your threat modeling list, because I think this is what Lockbit is also leaning towards, is that they're paying for that sensitive insider information, or what typically might be insider access even as well. But I think that is probably a great way to wrap up for the week. I want to thank you, Joe, for joining us this week. I want to thank you, John, as well, and thank all of our listeners. Make sure to please subscribe, hit that like button, check out the show notes. And speaking of movies with great synth soundtracks, check out Turbo Kid and the band Lamados. And with that, we'll see you next week on Application Security Weekly.